Okay, today we're going to use a demo that you've seen before. We're going to try to remind you about electron configurations and how electrons don't just exist in one particular area, but they could be in a variety of different energy levels. And we have some visual evidence we can see for that. So what you've got in front of you here is 5 salts, and these salts have different metals in them. This one here has copper in it, this has lithium, this has strontium, sodium, and potassium. And the reason I picked these 5 is they're ones that we can detect the different amounts of energy just with the naked eye. Now as you take a look at these, you'll notice that the copper salt definitely has a bluish green color to it. But the rest of them, you're going to take a look at these and there's kind of, different consistencies and textures, but a lot of them look pretty boring. Basically just white salts. Okay? Most of them are chloride salts as well. So it's strontium chloride and sodium chloride and potassium chloride. Now, what I'm going to do is I'm going to heat these up, and I'm not trying to get them to react with any oxygen. I just want to give them enough energy to get those electrons bouncing around. And when they bounce from a particular level they started at to a new level, remember they release a photon of light. Okay? And that light will come off with a particular amount of energy, and you can sometimes detect different amounts of energy just based on the color of the light. This is kind of a chemical signature for each of these elements. So the first thing I'm going to do is add some methanol. And this is basically just our agent to heat it up enough that we can see this happen, okay? But not so much that it actually starts to burn and react with the oxygen in the air. So each one of these is going to get a couple of squirts of of methanol. I'm putting it in the lithium salt right now. And we're going to light the alcohol that's in here on fire, just so that it will energize. Remember, we talked about this last year. There were several ways you could actually add energy to the system. You can do it in a spectral tube where you add it with an electric current. In this case, we're just adding it with another chemical reaction, and that's the burning of the alcohol. Okay. So we've got some methanol in each one of those. You put the methanol way back here so that it's far enough away. Now, some of these you can see right away, and some are going to take a little bit of time for the signature to show up. Remember, we're getting these electrons to bounce around. Obviously, the copper's got a green color. The strontium in the middle has that kind of reddish color, sort of a reddish pink. Okay? As we work on down, the last two look kind of very similar. It takes a lot of energy to actually get to see these different. You look at this and say they look the same, but if we were to have a device that could actually measure the frequency, you would see a much more orangish yellow color coming out of the sodium, and then the one on the very end is potassium. It's a little bit lighter. Can't always tell. The lithium in the middle gives you little flashes of dark pink every once in a while, but it's not showing up great. It just needs a little bit more energy to see that. What this is giving us evidence of, remember, is that electrons don't all just exist floating around in the same orbitals. There must be these little sublevels of different amounts of energy, and each atom is slightly different from the one that it's close to on the periodic table. And this gives us some evidence that those differences exist, and that's why we have to do electron configurations to map out where those electrons would normally exist. As you see this now, you can kind of see the two on the very end there, the potassium and the sodium right next to each other. The potassium has just a little bit lighter color to it than the sodium does, but not much. Okay. We have a hard time seeing the lithium, and that's because I couldn't find lithium chloride. We had to use lithium carbonate, and it just doesn't seem to get energized quite as easily. And this is just an example of why we need to go through and analyze those electron configurations, because no atom is exactly the same as a different one.